Okay, looks like I misspoke on example 5. The real problem with example 5 was the fact that the function was not defined at x equals 0, not the discontinuity. But I'm not going to go back and change that video. We'll just say that we fixed it now. So if you go back to example 5 and make a note there that it wasn't the continuity issue, it really was the asymptote, the fact that the function didn't exist at x equals 0. That's the problem, because here we go. We've got a piecewise function that's not continuous. And I was like, oh no. All right. So what we can do though is we can find area under the curve from, what are we doing here? -2 to wherever, right? Yeah. And it's constant from then on. So it's 5 from then on. We just didn't have the whole graph there. Okay, fine. All right. So that's what we're going to do. So we're going to find the integral from 3 to 8, but that's just this part of the function. It's the when it's just 5, right? So what you do is you're going to do the antiderivative of 5 dx from 3 to 8. And as you know, it's just a rectangle, right? So, but we'll do it as if we didn't know that. All right, so this would be 5x evaluated from 3 to 8. Okay, so that would be 5 times 8 minus 5 times 3. So that's going to be 40 minus 15, which is 25. And I know you're like, I know it's a rectangle. All right, but now it wants us to go from -2 to 4, the entire thing that we see here. Okay, so we'll just break it into chunks. So it's going to be the integral from -2 to the moment where this switches, which is at 1, of 3x squared, 3x squared dx plus, and then we pick it up the rest of the way from 1 to 4. So that'll be from 1 to 4 of 5, which you know is just a rectangle, and it's going to be 3 wide and 5 long, however you want to think about that. We'll do that in just a second. Dx. All right, but this one though, this would be the antiderivative of 3x squared, which is going to be x cubed. All right, evaluated from -2 to 1. All right, plus this rectangle. So this time we're just going to call it what it is. It is 5 by 3. Okay, instead of doing that. I mean, we could, but you know, we got it. All right, so here we go. Fundamental theorem of calculus. We'll put the upper limit in first. So it's 1 cubed minus -2 cubed, which is so cool that it works out and adds those areas together. That's awesome. So what we got here? So we got 1 plus 8 plus 15. All right, 1 plus 8 is 9. 9 plus 15 is 24. Yeah. It threw me off for a second because we went further on that one's 25 because we went all the way to 8. Okay. All right, that's it. Example 7 is done.